Hello viewers, welcome to this exciting video. In this video, we will be looking at the November 2022 Science Paper 2, Question B2. Question B2 reads, ethyl ethanoate CH3CO2 C2H5 can be prepared from ethanol and ethanoic acid. Okay, ethyl ethanoate can be prepared from ethanol and ethanoic acid. All right. A. Write the chemical equation for the reaction. Write the chemical equation for the reaction. All right. Here we are even lucky that they've told us that we are preparing this compound from ethanol and ethanoic acid. However, if you are not told the reactants, you can easily get the reactants either from the name or the formula. All right, how can you do that? So the first part, okay, now what we need to understand is that this compound first is called an ester. It is an ester and it is made when an alcohol reacts with a carboxylic acid. So in the name, the first part, when you are writing the name, in the first part of the name represents the alcohol. And the last part represents the acid, okay? However, when you are writing the formula of the ester, it is the acid comes first, so this is the acid. While the last part, this last part, C, is the alcohol. So from here, we can get the formula of the ester and of the acid, and we can get the formula of the alcohol. So I'll start with the alcohol. So since this is the one representing the alcohol in the formula, so I'll get C2H5. I'll say C2H5. Then to this, I'll just put an OH. Then it becomes the alcohol. So this is ethanol. This is ethanol. Then plus, okay? Plus. Then I get the last part. I get the last part, which is, I get the first part of the formula, which is CH3 CO2. Now, when I reach this part where I put O2, I will just add a hydrogen at the end there. Okay, I will add a hydrogen there. So this is my carboxylic acid. This will be my carboxylic acid. Then I'll just say will give us, then I write this whole thing, which is CH3 CO2 C2H5. Now, with this, remember, when we are writing the names of these compounds, we added OH to the alcohol, and we added an H to the carbon. So these will come, and it will be H2O. So they will form water because they are leaving these molecules to form a water molecule. So this is the equation for the reaction. This is the equation for the reaction. Then we go to B. They're saying calculate the theoretical yield of ethyl ethanoate, which can be prepared from 23 grams of ethanol. Calculate the theoretical yield of ethanoic acid, which can be prepared, can be obtained from 23 grams of ethanol. All right, now what I like doing is just putting a relationship. Now they're saying ethyl ethanoate and ethanol. So they've given us the mass of ethanol. They want us to find the mass of ethyl ethanoate. So the relationship is between this molecule and this molecule. Are we together? Okay. Now, what I'll do first is I'll try to check if the equation is balanced. Okay, so in this particular case, the number of carbons on the product side is equal to the number of carbons on the reactant side, same as the number of hydrogen and oxygen. Therefore, the equation is balanced. So 1 mole of ethanol produces 1 mole of ethyl ethanoate. Now, with this, what I do is I'll just say C2H5OH. Okay, this is being related to CH3CO2 C2H5. All right, now the question is the theoretical yield. So in this particular case, the yield will treat it as they're asking for what? The mass. They are asking for mass, and they've given us mass. So this is a mass to mass calculation, a mass to mass calculation. So I'll find the mass of 1 mole of ethanol, and I'll find the mass of 1 mole of ethyl ethanoate. So let's start with the ethanol. So it's C2H5. Okay, allow me to add this 1 hydrogen to the 5 so that I have 6 hydrogens. So the molecule has 6 hydrogens and 1 oxygen. Then I can now find the mass. So we've got 1 oxygen multiplied by 16, which is equal to 16. We've got 6 hydrogens multiplied by 1, which is equal to 6. We've got 2 carbons multiplied by 12, which will give us 24. So 24 plus 6 is 30. 30 plus 16 is 46. So 46 grams. So the mass of 1 mole is 46 grams. So I'll write under the ethanol, I'll write 46 grams. So this 46 grams is relating to the mass of 1 mole of the ethyl ethanoate. So allow me to rub this part because this is where I'm calculating the masses from. All right, then I will now fuse in 1 more molecule of ethyl ethanoate. We have we have 1 carbon, 2 carbons plus 2 carbons, so we have 4 carbons. So allow me to say C4. Okay, then hydrogens, I have 3. Okay, I have 3 plus 5, so I have 8. Let me just confirm this. 3 plus 5, so I have 8 hydrogens. So hydrogens 8. Then when it comes to oxygen, we have 2 here, so we only have 2 oxygens. We only have 2 oxygens, so O2. All right, then we can now find the mass of the whole molecule. So it is 2 multiplied by 16, which is equal to 32. And it's 8 hydrogens multiplied by 1, which is 8. And we have 4 multiplied by 12. 4 multiplied by 12 is 48, if I'm not mistaken. 12 by 2 is 24. 24 by 2 is 48. Then we add. So 32 plus 8 is 40. 40 plus 48 is 88. So we have 88 grams. So 46 will give us 88 grams. So after doing this, we now get what has been given to us. So they're saying when 23 grams of ethanol. So on the part of ethanol, I will put the 23 grams there. Then I'll relate it to x. Then we cross multiply. Okay, so when we cross multiply, we can even see here. You can see that the 23 is half of 46. So it means that I expect, this is just an expectation, I expect to have half of this. Now let's just see whether this will be true. So I'll have 46 grams multiplied by x. So I'll have 46 grams multiplied by x is equal to 23. 3 grams multiplied by 88 grams. So I would now divide by 46 grams over 46 grams. So this goes, okay, one of the grams will go, then I have 46. 23 into 23 is 1. 23 into 46 is 2. 2 into 2 is 1. 2 into 88 is 44. So I will have 44 grams of ethyl ethanoate. So X is equal to 44 grams. So 44 grams of ethyl ethanoate. So that is about the theoretical yield. So what is theoretical yield? This is the yield that is gotten from performing calculations using a balanced chemical equation. This does not show exactly what you will get when you physically do the experiment, because some of these reactants may contain impurities, and sometimes losses may be there during the reaction, so you may not get exactly what has been calculated. Hence it is called theoretical. What you get from the actual experiment is what is called the actual yield, because you've actually gotten that from the experiment. Okay, we got to C. C, if 33 grams of ethyl ethanoate is produced, calculate the percentage yield. If 33 is produced, so this is what was actually produced from the reaction, from the actual reaction. We got 44 grams from a balanced chemical equation, but in real life 33 grams was produced. Now they want the percentage yield. So percentage yield is equal to actual yield over theoretical yield multiplied by 100%. So what is our actual yield? Our actual yield is 33 grams. Our theoretical is 44 grams. Okay, multiply this by 100%. So the gram goes, okay, now 33 divided by 44. 33 divided by 44, then multiply that by 100. 33 divided by 44. So 33 divided by 44, okay, is equal to 0.75. Then multiply that by 100. It gives us 75%. So the percentage yield is 75%. So this is the percentage yield. The percentage yield is 75%. All right, we proceed to D. D, to which homologous series does ethyl ethanoate belong to? To which homologous series does ethyl ethanoate belong to? I think I said it in the early stages of the question, okay? And when I was talking about this, I said this belongs to a group of compounds called esters. So the homologous series is esters. So these are esters. These are esters. All right, viewers, thank you very much for watching this video. If you like the video, please don't forget to give it a thumbs up. If you're new to the channel, don't forget to subscribe and hit the notification bell. Thank you very much for watching.